Okay, matrices have order to them. What is an element of A sub, and I can't do the sub notes, so I'm going to handwrite them in, sub 2, 3. It's not 23, it's 2, 3 in matrix A. Okay, A23 means row 2, column 3. Row 2, column 3. So the first number is row, second number is column. Do you know the differences between rows and columns? Which way does row go? Nope. Rows are horizontal. Columns, like, hold up buildings. They have to be vertical. Right? Columns hold up buildings. So row 2 would be this row. Column 3, like a book, starting on the left. 1, 2, 3 would be this column. So what is the element of A23? 8. Okay, because it's where that row intersects the column. And because I was typing this, I couldn't do that for the bracket. If you would insert brackets around that, that's how we write matrices. Example 2 is the same matrix. I retyped it. You don't have to rewrite it if you don't want to, because it's the same. But different question. What is element A13 or A13? So it goes in order. Row, it tells you the row, and then it tells you the column. So once you've decided what it is, fingers in the air, well, with your partner, with a neighbor, fingers in the air, what is the element of row 1, column 3? With your partner, fingers in the air, with a partner, you need a partner for this. What is the element of A13? Row 1, column 3. Your nails. A little creepy. They're pointy. Good. Girls back there, what do you have? 17. Excellent. Row 1, horizontally. Column 3, 1, 2, 3. Column 3, vertically. Columns hold up buildings, so they have to be vertical. So we get 17. So those are elements. Okay. Let's see what we have next. Okay, you can represent a system of equations. Remember we graphed recently systems of equations, crayons, and we have the shading on the graphs. You can represent a system of equations with matrices. And to group the system, we do a brace. Brace are those squigglies. Bracket is nice and squared off. How can you represent the system of equations with a matrix? Well, there's order to it. You're going to have an X column, you're going to have a Y column, and you're going to have a constant column or a solution column. So, in this case, my X column would be the coefficients. 2 on top. How many X's are on bottom? 1, because it's 1X. So they have to be in like terms. My X's and then my Y's. So now focal order. 1 and negative 6. And then through the equal sign we actually do a vertical bar. For the constants on the other side. 9 and negative 1. Like so. Okay, so there's order. Again, the first column was x coordinate or coefficients. If you're missing an x in your equation, then you put a 0. If the other equations have an x and one of the equations doesn't, you put a 0 in the x position. Then this is the y coefficients. Yeah. Vertical bar replaces the equal sign, and then we have the constants. Vertical bar is just the equal sign. But it has to be in order. If your equations are given to you out of order, you have to rearrange them. X, Y, and then sometimes Z, depending how many variables you have. Okay, so this next one, can you write this as a matrix? Okay, try it on your own. When you think you have it, turn to your group and see if you have the same thing. Waji? Take that system of equations. System because we have multiple equations. And write it as a matrix. Now there's order. Remember, you have to have your X column, your Y column. Oh, look, we have some Z's. A Z column. And then your constants. If they're not in order, you have to use your inverse operations to get them in the right order. So you have your x's, your y's, your z's, and your constants in that order. And if it's missing a term, then you just put a 0. If it's missing a term, you put a 0 as the placeholder. Write the matrix, please. If you have to solve it, get it in the right order. Again, here's your hint. If you're missing terms, you put a 0. If it's not in the right order, use inverse operations to get it in the right order. So it's set up x's, y's, z's equals the constant. Okay, so I would start with the one that has all the terms. Which equation has all of the terms and isn't missing any? The first one, is it in order? Yeah, it's in order. Okay, Andrina, can you tell me what to write to represent that first row in our matrix? And what goes between the 1 and the 6? Vertical bar through the equal signs. Good, and that's in order, so we want to make sure our x's, our y's, and our z's are all in the right order. For the next column, our x's are lined up. So how many x's are here in row 2? 1. Oh, there's no y's, right? So make sure your z's go together. 3 and 12. So, for example, 4, we actually need to get the constant by itself. So we're going to solve it by solving for the constant this time. Plus 5x. We have 5x plus y equals 1. Who solved it? Move the 5x over. Okay, so everyone understand why? You have to have your variables on the left, constant on the right. Okay? So, Javiera, now that we've solved it out, what would I write for my final row? Great, thank you. So that's taking a system of equations and writing them as a matrix. And plural for matrix, by the way, is matrices, in case you're wondering. Okay? Now we're going to reverse it. Example 5. Hold on, let me put this up. What linear system does this matrix represent? So the last one we started with the linear system and then wrote the matrix. Now we're starting with the matrix and you're going to write the linear system. So matrix is going to have that squared off bracket. A system is going to have the squiggly brace. Can you guys see where the equal sign is in the matrix? So how many variables is our linear system going to have? 2. Good. Try to write the linear system, please. We'll check it in a couple seconds. Samuel, will you put your phone in your bag, please? I see some interesting things. How come people are only putting y equals 9? Because there's no x. Okay. You should get a 5, a 2, and equals 7. And they go in order. 5x plus 2y. And then the second one, there is no x, so we have y equals 1, y equals 9. Yeah? Pretty straightforward, right? Okay, now we're going to do the puzzle that you guys were trying at the beginning. We're going to try to solve this. System using me. Okay, so since it's a system, I'll put a squiggly brace. First, to solve, we're going to write it in form of a matrix. Katie, can you tell me what the matrix would be? Great. And the vertical bar, she's right, goes through the equal sign. And we make sure the x's were lined up, the y's were lined up, so we didn't have to rearrange. Okay, our goal is to get it in the form like this. 1, 0, A, 0, 1, B. Where A and B is our solutions. Actually, maybe we'll just call them X and Y, because it's a point instead of AB. Instead of AB, let's just avoid confusion and just call them X, Y. Because when we get our solution, what it's telling us is where these two linear lines intersect, and they intersect at a point, and points are X, Y. So we'll just keep it the same variable. Alrighty. So we kind of did this earlier. We have some guidelines we can follow. So here are your rules. You're allowed to switch any 2 rows. Switch any 2 rows. You can multiply a row by a constant, or divide. You divide any row by a non-zero constant. We don't want to times everything by 0. Okay, we were allowed to do that on our puzzle at the beginning. You can add one row to another. Add one row to another. And finally, kind of like that last step when we had to, when Chris was up here, we had to, what did we do? Multiply by 4 and subtract, something like that. You can combine any of these steps. Okay, so what you want to do first is examine what you have and see if any of the numbers are already in the correct spot. Do any of those numbers look like they're already in the correct spot? The 1. So I would probably not recommend switching rows in this one. If you found that, say, the bottom row had the 1 in the first column, the X column, then I would consider switching rows to get it into the top left location. But in this case, the 1's already good to go. Okay, so first, can you think of any ideas to help us solve for the top row? Or the bottom row? So this 1 is good to go. But is that 2 good to go? How can we, the 2 is supposed to be a 0, right? Let's think of ways of how we can make that 2 a 0. Minus 2 from everything. Because we have to keep in mind we're going to be doing that to everything. Okay, let's try that. So I want you to be writing each of your steps. So we're going to minus 2 from that whole row. And actually, I probably shouldn't use parentheses because that looks like times by negative 2. And notice I put it with the bottom row. Okay, now my matrix, the top row stays the same, so I rewrite it, keeping the top row the same. The bottom row, that's minus 2. 2 minus 2, 0. 5 minus 2 is 3. 4 minus 2 is 2. Okay. We're on our way. We have the 1 in the correct spot and the 0 in the correct spot. Just 2 more numbers to get in the correct spot. We want this 4 to become a 0, and we want the 3 to become a 1. What? Subtract which row from which row? Are you saying bottom minus top or top minus bottom? Because subtraction has order. And that would help get which one? A 0 or a 1 here? A 1. So we're going to take our top row and we're going to subtract every term on the bottom. Subtract, subtract, subtract. So we get 1 minus 0 is 0. 4 minus 3 is 1. Oh my gosh, what's wrong with me? I'm sorry. 4 minus 3 is 1. Negative 1 minus 2 is negative 3. And what do we do with those numbers? Question though, by doing this step, have we now changed our 0 to a 1? So let's try to think of maybe a different way to get this 3 to be a 1. Yeah. Right here on this step or at the very, very beginning? You want to add rows at the very, very beginning? And the point of that would be we'd get a 3, a 9. Oh, then we'll have a bunch of 3s. Should we try that? Okay, both of these are in a different order than I did it, but there are different ways to come about. Some are longer, some are shorter. Okay, so she wants to take each of the originals and add them. So we're getting 3, 9, and 3. And are you replacing the top row with this or the bottom row with this? Because the 1's already in its place on the top row. Okay, the 1 was already in its place on the top row, so we don't want to touch that. Let's manipulate the bottom row. And take out this -2. Ooh, look at all those multiples of 3. Ooh, that could work, because then we'll have 1s, and then we can actually subtract, right? Ah. Divide by 3. Notice I'm putting it on the bottom row, because I'm only wanting to do that on the bottom row. 1, 4, -1. What changes is just the bottom row. 3 divided by 3 is 1. 9 divided by 3 is 3. 3 divided by 3 is 1. Then I see some canceling that's going to happen. If I subtract 1 minus 1, I'm going to get that 0 in the left corner like we want. So let's take the top row and subtract each term of the bottom row. I don't do the add and subtract part really in a matrix because it's just side work. 1, 0. And then when I get that, I'm going to now insert it into the matrix. 0, 1, 0, 1, 4, -1. Ooh, we're close. Oh, I was like, I have something different. Guys, why did I make all these mistakes? That's a -2. My brain apparently can't add and subtract today. Guess what? When this is 0, 1, -2, this means we've solved for one of the variables. Which one have we solved for? Y. We know now that y equals -2. Okay, we're so close. How can we get that 4 to be a 0? We want the 1 on the top left, but the 4 needs to be a 0. Now I can't subtract 4 from everything, because if I do 1 minus 4, that becomes a -3. I want to keep this one a 1. Can I use the second row somehow to make that 4 become a 0? What? I can't hear you. I agree with subtracting 4, but we have to do one step first. If this is a positive 4, 4 subtract 4 would be 0. Can we use this bottom row to get a 4 somehow here so that we can subtract it? Times by, we can do a -4 and then we just add, or we can do a positive 4 and then we would subtract. Okay, so I put a -4 there. And just times the bottom row by -4. And the reason I'm doing -4 is because I want those to cancel out. Because I want them to cancel out. If this is a positive 4, I want it to go to 0, my options are multiply or add, but I don't want to change the 1. So if I times this guy right here by a -4, I get a 0, -4, and positive 8 on the bottom row. The top row stays the same. If I add the top and bottom, I'm going to get a 0 right there. That's what I want. Because 1 1 plus 0 is 1, so I keep the 1 in the top left like I want. 4 minus 4 is 0, so I get the 0 in the second spot like I want. 1 plus 8 is 9. What? Oh, it is a negative 1. Thank you. So my final matrices, I'm going to take this 1, 0, 7 and put it on the top row. And the bottom row remains the same, 0, 1, negative 2. So we found our identity matrix, 1, 0, 0, 1. And we found the solutions. The solution is a point, x comma y. What's the x? X is 7. The y, the 1 is in the y spot, so y is negative 2. Now, to make sure that's actually right and we didn't make a mistake along the way, you want to check. We check by plugging them into the original. You go back up to the top, the original was x plus 4y equals negative 1. X plus 4y equals negative 1. So what would I put in for x? X is 7 plus 4 times the y is negative 2 equals negative 1. Audrey, do you have all this on your paper? 4 times negative 2 is negative 8. 7 minus 8, negative 1 equals negative 1. We're halfway done checking because that came out as negative 1 equals negative 1, so it worked. You also need to plug it into the other equation, which was 2x plus 5y equals 4. Replace the x with your x solution you found, which is 7, plus 5 times the y. The y we found was negative 2. Do that math. Does it actually come out to 4? 14 minus 10, 4 equals 4. So we've checked. So we know we have the right answer. You can use that sink right there. All right. Everyone stand up, please. Okay. Put your phones away now. That breaks over. Right now, example 7, we're going to find the solution. This should be a little faster now because we know some ideas. It's kind of like a puzzle. I really like these because it's a puzzle. I always like solving puzzles. Alright, Waji, since you think this is boring, tell me please what the matrix would be. Because first we have to write it in matrix form, right? Not a 0. Where? Yep. And one more thing. Brackets. Yep. Okay. So remember, we're trying to get it in the form. Our goal is to get on the left-hand side of that line, we want diagonal 1s. And the right-hand side of the equal to line, put the calculator way down, please. We'll do calculators on the next problem. Will be our solutions, x and y. Now first, analyze your matrix. Do we have any numbers that are already in the right spots, especially 1s? No. Okay, so let's think of ways we could get either 1 in the top left or 1 in the bottom right. Okay. Plus 2 to all of them on the top. Okay. So we have, I hear minusing 3, I hear adding 0. Any multiplying options? See that 2 are pretty close to the same type of factor. Well, they're multiples of the same number. 3 and 9. So we make 3 be the opposite of 9. What's the opposite of 9? Negative 9. Can we make 3 be a negative 9? Yeah, by timesing by what? Negative 3. I want to times everything on this row. So on the outside I write times by negative 3. Then I rewrite the whole matrix, and I'm only adjusting the bottom row at this time. So the top row stays the same. 3 times negative 3 is negative 9, and that's going to be great because I can see that those are going to cancel. 7 times negative 3 is negative 21. 17 times negative 3, uh-oh, someone help me out. That sounds right. Negative 51. Now, you see how these are going to cancel? 9 minus 9 makes 0. So when I cancel, what row am I going to want to replace? The top row or the bottom row? Which one do I want that 0 first? The bottom row. So I'm going to take these, and I'm going to just add them straight up, because since they're all negative, it's really subtracting. I'm going to get a 0, a negative 23, and a negative 50. Let's try that again. What's that? Negative 46. And I'm going to replace it on the bottom because there's my 0. 0, negative 23, negative 46. On the top, I'm going to leave the top the same. So far we haven't done anything to the top. Now I have my 0 in the right spot, which is great. I divide by what? Yep, because look, these are multiples of each other. 23 doubled is 46. And if I divide by negative 23, I'm going to get a 1 in that spot. And I'll have a 0 and 1, and my bottom row will be done. So we're going to times by negative 23. Not times, dividing, aren't we? I did the wrong one. Divide by negative 23. I'm going to get, again, that top row is not being changed yet. We're going to eventually have to change it, but the bottom row is the only one we've been working on. Okay, Tyler, what's negative 23 divided by negative 23? 1. And negative 46 divided by negative 23? 2. So we actually just solved for one of the variables. This bottom row, that 1 is in which column? The X or the Y column? The Y column. X is first, Y is second. So we've just found that Y equals 2. We're halfway there. Any questions of what we've done so far? Now our goal is to get the top row, so that's 1 and 0 in the first two columns. Any ideas how to get it in 1 and 0? Add 2 to everything. Why do you want to add 2 to everything? I would work at getting the 1 first, before you focus on the zeros. The 1s are the tricky ones. Subtract 5. What would subtracting 5 do? Okay, other ideas? Okay, so you guys are really wanting to fix that one first. Okay, well, let's do it because that's what everyone's saying. Let's make that a 0. Okay, so she says take the bottom row And you want to do what with it? Because we also times it by 2. Okay? So, because it would essentially do the same thing, right? Timesing by 2 would give me a 0, 2, 4. And then your whole point of manipulating the bottom row is to cancel it to 0, right? That second, the y term, to 0. Okay, so you want to add a -1? Times, what were you doing? Okay, so she wants to multiply by -1. So that changes it to 0, -1, -2. Take the top and add them up. We get 9, -3, 3. Ooh, interesting. All multiples of 3. Okay, and you're going to replace the top with that. So let's rewrite our matrix, replacing the top. As you can see, there's lots of routes. So we don't all have to do exactly the same. Some ways are longer, some ways are shorter. So if you're figuring out a different way, that's okay. Okay. Now what? Divide by 3 to simplify it a little bit. That would give us, okay, I hear someone say, wait, divide by -3. You want to divide by 3? Okay, so 9 divided by 3 is 3. -3 divided by 3 is -1. Interesting. 3 divided by 3 is +1. I can see a 0 happening. Add the bottom and the top. Is that why you said no, use a +3? Because 1 minus 1, when we combine those, we get 0. Okay, so I'm going to just add them up. We're going to get 3, 0, and 3. We're getting close. We're getting very close. 3, 0, and 3. And the bottom stays the same. Now divide by 3, and I believe we are done. 1, 0, 1, 0, 1, 2. It is a lot of work. So our solution is a point. 1, 2. Where the x is 1, the y is 2. How do you know for sure that you did it right? With all those crazy steps. Plug it back in. Check it out. Make sure you check to verify you didn't accidentally do something wrong. We check by taking the originals. 9x minus 2y equals 5. And 3x plus 7y equals 17. Replace, Brian, can you put the calculator down, please? Replace each of the x's with a 1, and each of the y's with a 2. Does that actually equal 5? 9 minus 4 is 5. So, but you need to check out on all of them. The next one we're going to do is a 3 by 3, which you've already done a 3 by 3 at the very beginning of class when I gave you that puzzle. Replace the x with 1 and the y with 2. We get 3 plus 14, so it's true, 17 equals 17. That's how we know we did it right. Now the way I did on my paper was in a completely different order. But we still got to the same answer. So if you're doing it differently than your neighbor, that's okay. Okay, the last one I'm going to show you how to do with your calculator. It's going to be a, I think it's a 3x3 matrix. Where did I put my... Okay, the last one we're going to do on our calculator. Especially when the matrices get really long or you need to check to make sure you did it right. This is example 8. If you need a calculator, come get one, please. Again, what is the solution? (2a plus 3b minus c equals 1. Negative 4a plus 9b plus 2c equals 8. Negative 2a plus nothing, 2c equals 3. Okay, you ready? Everyone have calculators? You see a matrix anywhere on your calculator? Where is that? X to the negative 1. That's a little inverse. Okay, so in blue, so we have the green output, then we have math, and then right below it is matrix in blue. So we have to go second matrix. Okay? Then you need to go over to edit. We need to edit and insert our data. So go over to edit. Push enter. So what we've done so far is we did second matrix. Then we're going to go over to edit. We need to tell it what size of matrix we have. How many rows and how many columns do we have? Is it a 3x4 or a 4x3? And if you don't know, you can just plug and chug. 4x3, see it starts making it. Let's make sure that's right. Is that what we want? No. So you should do 3x4. And just make, oh, now we only have 3 rows. So it's row first, and then column. Same thing as the order we were talking earlier. Row first, and then column. So type in your first row, which is 2, enter, 3, enter, negative 1, enter, 1. Enter. The second one is negative 4, enter, 9, enter, 2. Just hit enter and we'll go on to the next spot. Negative 2, enter. Remember, there's not a B, so we leave a 0. 2, enter, 3, enter. Okay? So it was row times column when you set it up. Row by column. Okay, now we're going to go to the home screen and make sure it's what you want. Go second quit. Second mode has quit above it. If you go back to matrix, second matrix, your number 1 is now matrix A. Just push enter. Is that what we wanted the matrix to look like? Sorry, again I went second matrix, and I just selected matrix A is where you just put the name in. And then I push enter. Okay, now what we've been doing on all these steps is called row echelon form, reduced row echelon form, and there's a function for our calculator to solve for us. If you go back into the matrix, second matrix, go over to math, scroll down there. Actually, I think scrolling up is easier. RREF. So I went to second matrix. This time we went over to math, and we're going to B, where it says reduced row echelon form. Reduced row echelon form. We want B. So hit enter once you've selected B. Now it just wants to know which matrix do you want to reduce. What did we name our matrix? A. So we get A by going back into second matrix. Which one's A? Number 1. Enter. Aha! There's the solutions. Okay, and then we type in A. So we have 3 variables. A is, what's A's value? You can see the diagonal ones. A is 0.5. B is 0.6 repeating, which is the same as 2/3. C is 2. There's the answer. Okay. So, for your homework tonight, it doesn't say use a calculator until number 9. Okay? You're not using a calculator until number 9. So we are on page 380. Let's write it right here. Okay? We're doing, and first it's like just name the element, write it as a matrix. Those are easy. You don't actually start solving until number 7. Okay, so you don't have to go through all those steps until number 7. 1 through 14. Okay, you don't use the calculator until number 9. You can use the calculator number 9 and number 10 are the only ones in that section. Okay? Calculator only on numbers 9 and number 10. If it asks for the dimensions, remember it's row first, column second. Row first, column second. Calculator can only be used on numbers 9 and 10. So if it's not 9 and 10, then I should see lots and lots of work.